Bring it to the front.
I'll use whatever so that people can hear. Okay. Thank you very much. Okay, I'm Joel Halpern. This is Sue Hares over here. Martin Vigouroux, who helped us prepare this material from earlier material, the credit for the earlier materials at the end, is not here right now. He wanted to help also, but he's in transit. We're going to try to give you in 1 hour an overview of the routing area. That means we're going to go very quickly through a lot of material. The slides themselves are posted, so when you have more time, you can look back over it. Next. So we're going to try to tell you what the breadth of the work is, give you an idea of what we're doing, and there's a lot of different things we're doing in the routing area, and how it's divided into various categories. And Sue will go over the categories a little later on so that you can see that, because there are common themes in the way we approach things. There's mature work, there's emerging work, there's specialized work. And so the structure, most of this is one slide per working group. And the reason we have to go quickly is that's a lot more than 30 slides in just this area. So you'll see, next slide. We're not going to tell you how to do network routing. That's a whole science. We could spend a whole day on how do you do routing and all the variations. That can't do that today. Love to have that discussion, but that's not what this is for. And we're not going to talk about how you design routing protocols. There are many theories on that. It's an interesting discipline. I have a lot of fun doing it, but that's, again, not what we're trying to do today. And understand, the vast bulk of the work in the routing area does not depend on knowing how you design routing protocols from scratch, because we're generally building on earlier work. Even the stuff that's new work builds on existing work. So the old leads to the new, as in most disciplines. So routing has been recognized as a core division since, as it says, in 1989, when there were only 6 areas, but one of them was routing. I served as routing area director from 1994 to 1998. So we've been doing routing here for a long time, because that's what holds the network together. Got all these endpoints, and you got to get the packets between them. Everything that goes on in the middle, that's routing. So there are currently 7 areas in the IETF. The number has varied over the years. For example, what's now ART used to be 2 different areas. At one time, Ops was 2 areas, one for network management and one for operations. We merged them, we split them. Routing has been a stable area the whole time. There are 15 area directors. One of the interesting changes a couple of years ago is we added a 3rd area director to try to keep the work manageable, because as you can see, we have a lot of working groups. We have 27 working groups. It's a lot of work. So that's why there's so much. I mean, the IETF has 130. The number has varied, but it's pretty stable with 120 and 130 working groups in the IETF across all the areas. It's a lot of work. The routing area has also been pretty stable. You'll find we're about 1/5 of it throughout that period. And exactly what the working groups are, it's good when we close working groups. The goal in most cases is to create a working group to do something, have it get it done, and close it. Having said that, I will admit that routing is one of the areas that tends to have some very long-lived working groups, because we have to maintain the routing protocols. And since the problems keep shifting, there's always maintenance work. And we'll get back to that in a little while. Now back up one more. There was one more. So this last year, we published 250 RFCs. We published a lot of documents. And roughly 30% of those were 30% of the working group ones were from the routing area. It's a lot of drafts. We've got a lot of work going on. There are also 32 things that we're not working groups, so that we do, as an IETF, publish things that are not from the working groups. That's important. It helps us progress things that don't quite fit into anything. As I alluded to earlier, the point is that hosts are not directly connected. If you had to build the network by directly interconnecting all the hosts, it would be a nightmare. Routing is what enables traffic to get from a sending host to a receiving host. Whether that host is a phone, a tablet, a server in a computer room, routing is how you get the packets between. That's what it's about. So routers receive a packet, they look at it, they look at the destination IP address, they decide where does it need to go, and they send it on its way. Now, there are lots of refinements of that, lots of variations, but that's the basic problem. And generally, routes are known in a distributed fashion. There are some ways that we can program routes across portions of the network, but if you think about the network as a whole, it is a distributed environment, and routing is fundamentally a distributed computation. Everybody advertises a little bit, and based on what you see, you can figure out what the best way to get things to the destination. Now, best can be complicated because as an operator, for example, you may have business constraints. Certain paths cost more, certain paths cost less, certain paths can deliver things that you promised, certain can't. So best is not a simple parameter, but the basic idea is you get the information from this distributed computation and you do your piece of the packet forwarding in such a way that packets get to the destination. And we like it to be very robust so that even while things are changing in the network, because the network is not stable. It doesn't. I saw some beautiful research work about 10 years ago on how you could make a really, really small routing table if only everything would stay put. And all the links would stay up and nobody would move and no topology would change. We could then calculate these really neat tables. Yeah, except that's not how the world works. We are in a highly dynamic world. And so that's a lot of what routing deals with, is the dynamic behavior. So the routing area concerns itself with the protocols and mechanisms to route these packets. We talk about the routing control and the necessary forwarding state. The internet area deals with the actual packets on the wire. There are lots of things that are similar to routing but aren't, and we don't claim to do them. We will provide advice. We have experience with this distributed computation problem. So other people who have a similar problem, we give suggestions. We cooperate with folks on CDNs, on SIP distribution, on multipath TCP. You want to make sure that things work with the way the routing system works, but we don't try to solve everybody's problem for them. That's one of the rules, and one of the things that the IETF tries very hard to do is to leverage our range of expertise while working on things in different areas. Don't try to do everything in one place, because there's too much to do, way too much to do. So we can do informal reviews, we can give advice, but we don't try to do the work. So now next. But the other side of this is there's a lot of overlap. I mean, we have ISIS and OSPF. We're finally on the verge of merging those. But they were actually two different routing protocols. They behave differently in certain ways, but they have to do very similar things. But we've got lots of other routing protocols which also overlap. Babel has its constraints, but it needs to learn from other things. IDR, as Sue can talk about in excruciating detail, have to leverage everything else. The system has to work as a system, which means routing interacts with other things. And transport interacts with things. Congestion effects are very important. People try to adjust routing for congestion. That turns out to be very tricky. We have a lot of experience with how that can go wrong and how to do it in ways that are better. So there's lots of interactions across topics, which means scheduling all of this is really hard. There are 25 or 27 working groups, many of which ask for 2 sessions, some of which settle for only 1. But we only have so many slots. So sometimes we've got even routing groups competing with routing groups for time. So that means no one of you can follow everything going on, even in just routing. So we're trying to give you a sense of what there is so you can go on. I believe you take over. So there are two broad categories here. One is on maintenance and one is on new work.
And I will pick it up from here. So maintenance are old working groups that are long established protocols. We have to keep maintaining them for like BGP. BGP still, oh, closer to the mic, thank you. We have to maintain protocols like ISIS, BGP, MPLS, they run the internet. So, and there's plenty of extensions because as you've experienced in your own environment for your own customers, the IT technology really turns over every 2 to 3 years, whether it's for your home, your mobile phone, and then we have some new work. We have some ideas for specialized protocols or new protocols for routing applications. Go ahead. So let me go through the division. We have core routing protocols, we have specialist routing protocols, we have sub-IP, we have routing support or operations. How do you configure? We have routing services, we have things we call experiments. There are successful experiments for the most part, and we have closed but not forgotten. It's important to get done with the set of work and close it if you can. Go ahead. So let me go through the core routing protocols. These are fundamental. These protocols are usually in maintenance mode, although maintenance mode may be some substantial changes, but it just means that these protocols like BGP, ISIS, OSPF, MPLS are widely deployed. New work is treated with a high degree of caution. We don't want to break the internet. Okay, go ahead. OSPF. Okay, these are one of the SPF or shortest path distance protocols. And the work of maintenance is in the OSPF group. There's OSPF v2 for IPv4, there's OSPF v3 for IPv6, and the extensions are really better routing metrics, how to make sure you can get there, better scaling, better links, because we keep having newer and better links, and support for requests from other targeted working groups, such as MPLS, CCamp, which is doing some calculation, Spring, which is doing source routing, and Bear, which is a very interesting new approach to multicast, and then support for segment routing, if you've heard that sort of buzzword. Go ahead. ISIS is the old ISO protocol that started when OSPF and ISIS were interchanging in the work in 1987. Much of the work that mirrors what's done in OSPF, there's a new version wasn't needed because ISIS can share v4, v6, and other things in there. So again, the extensions look the same, and we're hoping to merge the two groups. Next one. IDR is one of the groups I co-chair, and it's probably it's BGP, and BGP is what you use to communicate between maybe large providers like AT&T. You'll find that it's used in many data centers like Microsoft's data center or Facebook's data center, and it's essentially in maintenance mode. We take our input from the GROW, which is an operations group that says these are the things we need in our BGP operational networks. And BESS and Spring have protocol additions. BESS is providing L2 VPNs, L3 VPNs, and other things, and Spring is providing source-based routing. So there are two important changes that are going on right now. There's the link state, BGP link state, or BGP-LS, which is exporting data on the routing information for traffic engineering. So you can pick the paths you're going through. And that's stuff that goes into calculation SDN boxes, sometimes just data to manage the network. And then flow control specification, which is a way that you can use to send denial of service filters throughout the network using BGP. Next one. There's CIDR. CIDR was created, and it's one of our closed working groups, but we introduced it because it was doing secure BGP. And it's trying to get rid of problems about fat fingering, like the operators type something and oops, all the stuff that was supposed to go to HP goes down some small place. That actually happened, or deliberate hijacking. The working group developed something that sat on top of a public key infrastructure. It devised a way to sign the route, so you know it comes from just your network to another network, and it has a way to distribute keys. So this is where we're hoping to go forward. CIDR has now closed its door and it's gone over to the operations area where operators and networks will say, how do I use this? Is this protocol really sufficient as it is? Go ahead. PIM is used for multicast. It's another one that's gone for a long time. It started with PIM sparse mode, and that's pretty much what's been deployed, but it also takes up IGMP and MPLS. So your local laptops use IGMP and MLDP if you're V6. It used to be in the all split, but it also is now working very closely with another operations group called MBONE. Notice IETF will have some protocols developed and then hand them over to the operations group where operators come and focus on, am I getting what I'm needing? Either operators in large enterprises, small enterprises, or provider networks like AT&T, Verizon, NT. Now there's also a maintenance mode for PIM, and it's trying to, again, improve the security and the scaling. You're going to notice I say that over and over. We just keep trying to refactor and make sure the stuff grows with the demands that users place. Go ahead. Now, Spring was a new working group that tried to take on a new look at source routing. You notice in routing we say, well, that's one idea we've had for a long time, but now we're going to take a new twist. Why is that? Because the needs of the network change. You're going to hear it from me again every 2 to 3 years. And so sometimes an old idea we take off the shelf and said, that'll solve that problem. And the complementary building blocks are being worked on for MPLS, IPv6, and routing protocols are added to try to make this source routing work in the new area. And the source routing is trying to help carve pathways through lots of networks or carve pathways inside of data centers. It coordinates with MPLS and, go ahead, 6-man for INT. Now, let's talk about the specialist routing protocols. These are routing protocols which might not be deployed as the other one across the whole internet, but they might be deployed in your home. They might be deployed in a subset of networks. And these environments divide very special routing protocols. The devices may be constrained. You may have constrained in sensors networks. It has a cost of routing dates may be high, so we're really looking at how do we actually constrain the information sent. So these specialized problems give rise to these targeted working groups. Go ahead. So we have Babel. Babel is for your home network. It's a place where you can have wired and wireless mesh networks. It's an augmented and rethought distance vector protocol. One of the earliest deployed routing protocols was a distance vector protocol. And currently it's an experimental RFCs, but the working group, the IETF saw enough value in the experiments to say that needs to be standardized. It needs to be ready for home network devices. And so it's upgrading its specification and it's putting management. Now you're going to hear a couple words you haven't heard probably before. Yang. Yang is just a data modeling language that we're now using for our management, because our idea is to have one network management protocol and switch in a whole lot of data models. Sounds like things that are being used in computer science all the time. And Babel is the mandatory protocol for HomeNet, and that's where it takes a lot of its input. Go ahead. MANE is something that, again, has been a long time. It started with people who had military networks where they drove around in Jeeps and wanted to be connected. It considers battlefield environments, emergency response times. You heard the hurricanes, people who come in and they drop in after the hurricanes or the floods or the fires with radios on the back and create individual networks. So that's sometimes the internet of developing nations, but as you saw in several of the responses to problems across the globe. Now the outstanding working items are trying to make sure you can get the right link characteristics, because you can picture if you're being dropped into a hurricane, you need to know if you think the link is good or if another link is better because you've got line of sight. And there's going to be a lot of additions to OLSR. OLSR is another variant of a protocol like ISIS and OSPF. Again, we have probably 2 to 3 algorithms: distance vector, link state, and something called policy routing, which is IDR. So again, we're looking for security and manageability. Go ahead. Role. This is a really interesting thing. This is about a place where you have maybe sensors or little devices or maybe even factory networks where you can't guarantee that there's really good network connectivity. If you're in a factory, there's all this noise, mostly electromagnetic noise, and you have to deal with it. So they may be ad hoc devices like in MANET, or they may be wall plugs, or they may be something on a pole, like an electrical pole. And this group has worked at trying to create networks that are stable in that environment. And they've actually worked on good multicast compression of routing information, because there just isn't a lot of good bandwidth in the factories, or if you're an electrical grid out on a pole in the rural area. So I think I've gone through that. Next one. DetNet is another fascinating new thing. This is where people who really want a network for high quality video, maybe they're gamers, maybe they're providing medical technology, and they want to have layer 2 and layer 3, and they want tight bounds on loss. If your doctor's doing one of those robotics thing, you want to make sure if he's having surgery that he has low loss of data, that he has low latency, and everything works fine. And these networks are tuned for that environment. And the data plane has to be compatible with the IEEE time-sensitive networking, which is, again, looking at things like this for good video or medical, and it will use MPLS or IP as the data flow. The use cases are, again, audio, video, electrical automation systems, if you're in a factory, and cellular radios. Okay, next one. Sub-IP. Sub-IP was for a short time an area with its own director. That's when MPLS was first being deployed, when we had new layer topologies like ATM, or we had new optical. Go ahead. So MPLS is the largest and well-known. How many people know about it, have heard the word MPLS before? Okay, so we're at least in that realm. It's the largest. It's usually across the world. It's been used for large providers. So some packet you have transmits it, at least to get here it does. It has several protocols. It has LDP, RSVP-TE, extensions for OSPF, and MPLS-TP and OEM, which is the operations, the management. How do you test these links? And so while these aspects of these things are in maintenance mode, because again, every 2 to 3 years life changes, there's always a little bit of revision to make sure it stays capable. And it generates at least 2 to 3 RFCs to keep going with that. Possible work that's coming is OEM security. Notice we keep saying security because the attacks are going up, the network keeps thinking about it. Go ahead. CCAMP is a generalized MPLS. So we have specific MPLSs, and then we have a generalized MPLS, and they work very well for the fiber optics. There are these very large fiber things, which are OTN, which are basically, here's MPLS and there's fiber that's been directed. And that generic MPLS added additions to existing protocols, RSVP, OSPF, ISIS. And it also worked down to the very fiber and to the photonics. So what happens is they can now get very good failover time, sub-second failover time, and they continually work to get better because the fibers do get better over time. Go ahead. FlexGrid was one example where things are changing. And the data centers are picking up the fibers, so you see we're getting another use case besides just long haul. The L2TP is a seasonal working group because it has layer 2 tunneling. And this is an example where a working group will come up and it will say, hi, we've got some work to do, and then it'll go away. We call that going on hiatus. The hiatus is like, I'm going to sleep for a while, and when you have more work, wake me up. And it's currently working on a Yang model. Go ahead. So T's, now this is an interesting new working group. You know, the data centers have a great deal of data, and they're trying to figure out how to get their data between the various groups of clusters of computation or storage. And so they need traffic engineering. So do networks like bringing it from the US to Singapore. That needs traffic engineering. So these traffic engineering was first formed by the MPLS and CCAMP to take this specific work and focus on it to get it done. It handles high architecture and it handles management together for this traffic engineering for either the data center, provider networks, and maybe even for small networks where they might not have enough bandwidth. So it has oversight and it's doing some really exciting modeling work for traffic engineering, and it's working on the foredge of trying to provide quick configuration. You might want it for your company or for your home because you want to be able to get just the right bandwidth, and they're working on new configuration models to do that. They're also working on segment routing. How many people have heard the phrase segment routing before? Okay, well, you're going to see this in lots of our pieces. Go ahead, next one. Trill. Trill is another working group I charter. It was developed as an alternative to 802.1AQ, which is ISIS for layer 2. Trill is ISIS for layer 2, and it provides a protocol that's transparent to operation for bridging. And they really can't see it. It runs ISIS in the center, but it provides a seamless bridging. So you plug it in and it just works. And it supports multiple destinations. It's been used in data centers, and it's been used in some campus networks, both education and some corporate campuses. It's currently doing the same sort of things that you've seen from ISIS or other things where it says, okay, now we got one topology. Can we have a virtual topology with just some of you? You know, it's like a friends network. I just want to talk to some of my friends. Okay. And you're seeing that because the data centers really do need sometimes one cluster to talk to a second cluster. This work is going to be completed by March 2018 and will probably close or go into hiatus. Probably this one may be a hiatus moment. Am I on your turn? Or am I got one more? Okay, so routing support and operations. So this is one of my passions, is because IP started out with a lot of hand configuration, and we've tried to work step by step to get better. Because one of the things that you do is you say, I want to configure a network. And if my little phone app can be done in hours, my network connectivity should be done in minutes. And the problem is the automation tools have traditionally lagged behind. But as I've said, with a new approach that says we'll use one protocol on a whole bunch of data models, we hope to change this. Now, the operations management, the operations administration and management, or the OEM, is a set of tools that are actually helping you monitor. So you combine configuration with these monitoring tools, because when you have a connection to your home, does anybody ever have problems with it? I sometimes do. And I complain and say, you know, this connection is bad, and I have my own tools that run it, but we want to be able to have that for everyone. So you can say, my tools are bad, and the people running your network can say, yep, you're right. Okay, so BFD is one of those tools that we use because it's a short hello. Hello, I'm here. Hello, I'm not here. Or hello, I heard you. We thought it would be a short-lived group because it was a simply hello packet. Am I getting my packets through? Are you up? But it's found to be useful in so many working groups. We keep thinking it's going to get done, and then they add a few more. But its current focus is multicast and seamless BFD for end-to-end monitoring. Again, if you're at the end where you want to say, can I get there? You might want to say, hello, are you there, to the remote end, and have it come back. Okay, IR2S, this is another working group I chair. This is one which is a new concept. We're thinking that the routing system needs a high bandwidth programmatic interface, because with SDN, with some of the NFV functions, with some of the very basic needs for these monitors, we wanted to have a high-level interface that could install routes from RIBs, that could learn about topology, that could program routing policies. And this can be done from an SDN controller or a white box controller or something down, and it would work through these standard protocols with some revisions to the concepts, traditional concepts of configuration to make it dynamic, so that when I need to monitor, you can do that. And when I'm done, you can say, go away, and the monitoring will go away. The working group chose Yang and used Netcom Frescom. Go ahead. PCE was initially considered to be something like what we now have is SDN, but it predates it for years. And it said, maybe I have a really fast computation machine over here, and I should be using that instead of this really expensive router. So PCE allowed to be able to have computational paths. Now, it handles these sophisticated computations, and it is an interactive protocol with the networks. It will say, oh, I've got a network event, and it may have several places within the networks that they've offloaded this calculation. What's the benefit? If you have photonics and you have thousands of photonic paths, perhaps you want to pick 3 or 4 to light up. And you suddenly discover you have more traffic, so you light up a few more. This PCE can help you do some of the calculations. It will report network events, it will supply updates, and it will have new path setups. It encompasses some of the segment routing, and its future cases are coming from the TEAS working group and sometimes from the INT, from the 6TISH and the DETNet. Okay. So again, you're seeing that old protocols or old concepts are continually being reused in the next generation of routing. Why is there a value for that? The value for that is because we don't have to remake everything. The routing group has what one might call a plagiarizing moment. Don't hydrize, plagiarize, because we want to reuse technology because it's tested. It takes a long time to get a good routing protocol tested.
Thank you. So the next category we're going to talk about are the routing services groups, because we use routing to deliver just plain packet forwarding, but also to deliver enhanced services. VPNs at layer 3 or at layer 2, pseudo wires, which we want to make the network behave as if you actually had a real wire between the 2 edge points. So these things deliver services. They leverage all the routing technology. So we do it in routing, and it's part of this work. There's been a bunch of new ideas in there and consolidation of working groups. Next. So one of the ones we have there is the BGP-enabled services, because a lot of the services have to cross operator domains. You want to be able to get your VPN from here to where you are, even if that's across operators. Therefore, you want to use BGP, which is the interdomain routing protocol, to support these things. So the biggest focus right now is what's called eVPN, which is Ethernet VPN, so that you're getting a layer 2 service using BGP to carry not just where is the service, but where are the individual MAC addresses. So it gives a very fast response time for knowing things. You don't have to flood packets across the operator domain. Flooding is expensive when you're talking about across the internet. And so because it's BGP, of course, it coordinates very closely with the IDR working group. A lot of the work is MPLS focused, so that's coordinated. And NVO3 is a working group in the internet area about how you build overlays for data centers, which, since overlays are often delivering layer 2 services, overlaps very heavily with this. Next. PALS is the specific group concerned with pseudo-wires. They also do some other LDP-enabled services, but their focus is L2 VPNs that are not driven from BGP. And so they get an Ethernet-style service that looks like a wire, and they have a very careful definition of what that means and what the constraints are and how to make that work using things like RSVPTE and LDP. So it's the converse, if you will. BES is on the BGP side, PALS is on the non-BGP side, and they go together. Next. Okay, I guess we have NVO3 these days. One of the things that we do is we move working groups between areas when it seems like they fit. So I'll be talking about Lisp later. Lisp was in the internet area, it's now in the routing area. NVO3 was in the internet area, it's now in the routing area. Because we looked at it and said, the control structures are becoming the focus. But it's also doing a data encapsulation. They're agreeing on what's called the Geneva encapsulation for delivering overlay services in data centers. So there's a long time that was spent on, do we use VMware's VXLAN? Do we use Geneva? Do we use GRE? What do we use for this? A lot of debate. Right now, control and security, imagine that. How do you secure this stuff appropriately is a very big issue, because you're talking about stuff that's operating at packet times, but that wants isolation. You don't want tenants getting mixed. That would be very, very bad. So they're trying to find the right balance in security delivery in there. Next. Service function chaining, which is one I happen to co-chair, is concerned with delivering traffic to the right places. It's a little different from classic routing. Classic routing is about delivering packet to the far end where it's addressed. But operators deliver services, whether it's firewall services, URL filtering services that are mandated by governments, content transcoding services that help cellular behave well. They deliver transparent services. You don't want to have all of the packets from all of your users going to all of your functions. Makes scaling really, really bad. So service function chaining is a way to control which packets visit which services. RFC 7665 describes the architecture. The network service header ID describes the encapsulation mechanism we're going to use, because it is another overlay. It's an overlay with path identification and metadata. The IESG approved last week the publication of the network service header as an RFC, a proposed standard RFC. We're now moving the work forward on OAM, on security, and on related issues. But OAM, operability, and security, where the work is. Next. So, looks like we're actually ahead of schedule a little bit, which is good. So if you have questions, you can ask, but we got a lot to cover. There's one more category of things we want to talk about. We encourage people to do things that are not necessarily obviously correct. Take risks, experiment. So we charter working groups to produce experimental results. And then we look at the results and say, is that proving useful? If so, we move it to standards track. But it's good. I actually wish we had a few more experimental things, because if you're going to do experiments, every once in a while you ought to be failing. Otherwise, you're not experimenting enough. And we had a very good track record of successes. So it's the way it goes. So one of them is beer. It's basically, some folks looked at the way multicast scales, and they said, this is painful. Why does it hurt so much when I want to carry multicast across my domain? And they said, what if I could mark in the packet the multicast tree? And they thought about it a bit, and it's not obvious how you do that, but they came up with a very good way to do it. And yes, it changes the forwarding behavior of routers, so it's risky. This is asking people to step up to a major change, but if multicast matters, and in certain environments it matters a lot, this is a viable way to do it that scales much better. However, you got to do it without replacing all the routers in the internet, or you can't deploy it, because if you have to replace everything all at once, no deployment. We had, back in the early 80s, we had experience with flag days. We learned, don't do that. You cannot replace everything at once. You can't even, you might think, well, okay, look, deploy the new software in every place and then turn it on all at once. Sounds great, blows up in our faces. So we try to learn our lessons. So it's a very enthusiastic working group. They're producing their experimental RFCs and already talking about moving to standards track, because vendors are implementing it, customers are using it. So we're really moving forward very quickly on it. That's what we like to see. Next. Locator identifier separation is a major problem. The very, very short form of this problem is an IP address represents both who is communicating and where they are in the network. As Yakov Rector used to say, either the IP addressing has to follow the topology, or the topology has to follow the IP addressing. Well, that's because it's doing two things. It's forwarding, which is topology, but it's also identity. So for the last 10 or 12 years, we've been working hard on how can you separate them. One of the approaches to that is Lisp. I co-chair the Lisp working group. And it started out as experimental RFCs. We published a whole set of experimental RFCs on the encapsulation, the mapping system, so that you can get from an identifier to a locator to deliver packets, all of those things. It turns out to enable a very large number of overlay cases. It's really good for large-scale dynamic VPNs, for data center overlay. My apologies. For a lot of things, we are now working on new RFCs that will move it to the standards track by focusing on the use cases that have turned out to matter. That's one of the interesting things. You may think you're building the solution for internet scaling. That's what the inventors really were after. But it turns out what they built was a really great overlay management technology. So we're going to standardize it for that problem, because it works really well for that. Next. There is a little bit of catch-all work and specialist work that doesn't fit. Sometimes the area directors just take care of it. They'll say, just give it to me, I'll take care of sponsoring it. But sometimes we do a working group for a while to take care of it. I don't even remember what we've got in this set. Let's see. Next. I guess this was the only place we could put RTGWG. This is an area-wide working group. It serves to take work that doesn't fit anywhere else. So it's actually a long-lived working group, but what it happens to be working on at any given time changes, because it's got, what do we need to spend some attention on? We don't want to spin up a whole working group for it. So that describe how routers can improve routing success, to catch-all. We use it for mini BOFs, so that, for example, if you've got just want a chance to present to routing people a new idea, we do that at RTGWG. Everybody listens, people comment, people raise issues, and then we can see if there's enough interest to move it forward. It serves as an incubator for a lot of ideas. And lots of people are talking about it. There's all sorts of work. So the one thing, mobile edge computing is another example of things that come up there. Yang, Sue mentioned Yang. Many years ago, we had SNMP, Simple Network Management Protocol, but it wasn't simple. And the structure for management information for SNMP was even harder than the protocol itself. And nobody was doing configuration with it. Turned out there were some good reasons for that. So we went back to the drawing board and said, can we design something that actually works, that people can actually use for interoperable configuration of network devices? And we developed in the operations area the protocols for netconf, and the netmod working group defined the language for describing that work, which is Yang. Yang describes the information that you're going to manage. You can then exchange that using XML or JSON, but the description is in Yang. It describes the managed objects that we need. It is not object-oriented. It is very much network management-centric. It is built to solve the network management problem, and it is getting tremendous uptake. It's even getting used for a lot of other things. I won't waste time on that, but it's tremendous uptake. There are 120 active IDs with Yang in the title. There's open source work. I2RS, for example, which Sue was talking about, is very focused on using Yang for configuration. We try to put the netmod working group can't home all of the Yang work. That would make no sense because they don't have the experts on what's being modeled. So the working groups in the routing area are responsible for their own Yang models, but they have to work with the netmod guys to make sure they build consistent, workable Yang models. And for things the way we don't have any place to do it because it's old models that we need to refresh, we do it in RTGWG. Next. The IETF has birds of a feather sessions. We have some rules on that. No topic can have more than 2 birds of a feather sessions. If you can't figure out what you're doing in 2 sessions, you probably don't have a clear enough idea, and we'll generally warn you after the first one, you don't know what you're trying to solve. Because people have a tendency, somebody wanted to do a working group on SDN. Well, what's the work? What's the problem? Somebody wanted to do a working group on cloud. What's the work? You have to focus on an achievable topic. So BOFs exist to allow us to have a discussion on a topic and then to drive to clarity on what is the work that needs to be done. We have a companion organization, the IETF, I'll talk about it a little later, where much fuzzier things can be done, but they still need to be progressing. But IETF engineering groups have to be about engineering something with a specific goal and a clear understanding of what we're doing. So this session, we're having a non-working group forming BOF on data center routing. There are about 6 different proposals for ways to improve routing behavior in highly meshed leaf-spine data center networks. Because if you just run ISIS or OSPF on a leaf-spine network, you see this massive explosion of information that's not doing you any good at all. And everybody's going, there's got to be a better way. And people are finding many different better ways. And so we'll be exploring all of those. What is the problem we need to solve? What are the constraints? What are the ideas in this Birds of a Feather session? And it should be an interesting discussion Wednesday. I believe it's Wednesday morning. Next slide. We do close working groups. That's a good thing. It means you laid out an achievable set of work and you did it. The Forces working group that I was involved in for many years. We got the work done. We closed the working group. It's not that what you're doing is dead or pointless, but rather you've done the work. Let people go, implement it, use it. If we need to wake it up again, we can. We're good at that. But focus on using it. So some of them are antiques. RIP and RIP v2, Sue said, really old distance vector protocols. They have some interesting problems, but particularly in terms of the complexity you could implement easily, they were really easy to implement in the late 80s and early 90s, and then later 90s for RIP v2. And RIP v2 had to be done because the original RIP encoded IP address classes in its underlying mechanism. Whoops, we moved to a classless internet, you can't do that. So we had to revise it. Very simple protocol, still out there, people use it. VRRP is a beautiful piece of redundancy that's used all over the place. The working group is closed, we got it done. Everybody uses it, it's really great. Forces I've talked about. You can find the list over there of all the things that we have done. And there's a lot of interesting work in there. Next. One of the ways the routing area gets its work done, and this has now become common to most areas in the IETF. It's not all, I think, but most. I think. Actually, maybe all of them have it now, is directorates. So you know that you've probably heard from other places. We have area directors who are responsible for the area. Area directors are human. They can't do everything. We have 3 area directors in routing. They still can't do everything. So what we have is a set of people who advise the area directors. They're selected by the area directors. They serve at their pleasure. And their job in the IETF terms is to provide advice. So we have 46 members on the routing area directorate. That's because we want to review a lot of things. We want to do early reviews to look for, are there serious problems here that are being ignored by this working group, so we can call attention to it early. In every piece I've ever worked on, I would much prefer to be told early, you're ignoring a hard part, than to get all the way through and think I'm done, and then have somebody say, oops, you forgot something important. So we try to catch things early. That's part of what the routing directorate does. Different areas, the directors have different jobs, but the purpose is to provide good quality and to look at routing issues in drafts outside of the routing area. Because as we said, there's overlaps. There's routing issues that other people come up with, behaviors, people make assumptions about what routing can do, and sometimes it can't. And we'd rather catch that and say, you know, the system doesn't work the way you understood it. We are all very skilled here, but we also all make mistakes. More eyes looking at things early across areas is really, really helpful. So there's some coordinators, John Hardwick and Amy Yee, who are a big help to folks like me who serve on the routing directorate, because they take care of who's asking for what, making sure it's timely, the people who are requesting are getting timely answers, all of those other things. The ADs or any working group chairs can request reviews. The rest of this doesn't matter. We try to do it in a really timely fashion. Next. The real message I want to get to you guys is there's lots of ways to contribute to work at the IETF. We want you to participate. That's why we're taking the time to try to give you a sense of the breadth of all of this. Get on the mailing lists. Watch the discussion. Participate in the discussion. Once you know what's going on, if you have good ideas, write your own internet drafts. Bring them forward. But there are also other ways you can help us. And that's the core way is contribute. Review drafts. I don't know a working group that can't use more reviewers, because the big challenge is extra eyes looking at things to say, what did we miss? Because it's very easy when you're working on something, you're neck deep in it. You assume, you know how it all works. You assume the words say the right thing until somebody points out you said exactly the opposite of what you meant. Please catch that early. Help me. It happens. The number of times where I've seen that is surprising. But yes, you write exactly the wrong thing. Minute takers, jabber scribes, we'd love the help. We appreciate everybody who's willing to do that. If you get a little bit more experienced, become the working group secretary. That'll let you see the process, let you learn how things work. We as chairs really appreciate our working group secretaries. They help us function. And it gets you visibility into what's all this process stuff. And then shepherding documents. Frequently chairs shepherd. We can use other people shepherding. It helps distribute the work and gets more people involved, and we're happy to have you involved. So there's lots of ways to help. So next. And there's lots of work in other places that overlaps with routing. Maybe the right place for you, because of what your interests are some of those other works. The amount of operation stuff. I mean, if we can't make these routing protocols operational, if we can't use them in the real world, we've wasted our time. So operationalizing these and meeting the operational constraints is very important. You can see a number, we're doing operations and management, deployments, global routing operations. There's a lot of work in ops that really is core to routing, but the key is operational requirements, and we try to drive that. The internet area, of course, overlaps with routing. The distinction, we draw a line and say this is routing and this is internet, but they live hand in hand. So the internet area's 6-man discusses packet forwarding behaviors and what can you do in the middle, because they want behavior, they want functionality, but it's got to be informed by what routing does and what routers can do. So there's a lot of overlap. HIP was an interesting one. Sue, you've gone back up one more. Home networking, Sue talked about. 6TISH is a time. There are places where you need real understanding of time. And it turns out time is a really complicated thing. You think it's a really nice, simple thing. It's not. Frightened me when I discovered that. And performance measurement, next. So as I alluded to, we're almost out of time. The IETF does a lot of things. They do research. Their job is not to look at things that are ready for engineering. Rather, their job is to discuss what would the internet implications be for this piece of technology or that piece of technology? How could we do this kind of thing in the internet? So there was an SDN research group because it was, what's the implications on the internet from the deployment of SDN? Currently, there's global access, network virtualization, network coding, which is a different kind of thing. How do you put information into packets for redundancy? Path-aware networking is a new one that's trying to see, well, if you have specific constraints, maybe you need to know more about the paths in the network. And of course, IoT thing-to-thing research group. Next slide. There is an independent stream. Not everything we publish has to go through the ADs or through working groups. If there's informational documents that you think would benefit the IETF, bring them to the independent, but they don't fit, maybe the right answer is to bring them to the independent stream editor. Neville Brownlee is currently the editor. Adrian Farrell will be the editor. Lots of interesting work gets published that way. It's really nice and varied work. These are links to things that you'll need. Next slide. Lots of thanks. By the way, I wanted to add a thank you to Yoav for providing a laptop when we couldn't connect our laptops. This material was, back up one, please. This material was based on work from Adrian Farrell and Jeff Haas. So we reused a lot of their slides. We did ask all the area directors, all the working group chairs for input. The area directors helped us get this together, but we've been doing this. So I hope this was useful to you. I believe we are now out of time, but if somebody has a quick question or two, we can probably answer it. Oh, there is a survey. You can, that's the link. The education people, the people who organize this work, asked us to please let you know there's a survey so that you can tell us what you would like to see. What works, what doesn't work, what more do you want? So, any questions? Okay, thank you.